Good evening, guys. Good evening, everyone. So I hope everyone joined this session. Yeah. So what are we discussing in our last session, guys? What are we discussing? We have discussed about the statistics part, right? And in the statistics, what is the concept that we are discussing? What are all the topics are we done with? We are done with the qualitative and quantitative, right? We're done with the hypothesis testing. And we started with the t-test, right? So what is t-test? What are the different types of t-test available? See, one sample t-test, an independent two sample t-test, and the paid t-test, right? Remember? And what is the main purpose of the t-test? To compare the mean and determine its differences, right? If there are any differences in the statistical, if there is any difference significantly, then it will be determining it, right? Just a moment. Okay. So, yeah. Akshay, brief summary in the sense like we have discussed about the types of the data, qualitative, quantitative, and followed by we have discussed the central tendency. And after that, we have more into this hypothesis testing. Yeah, hypothesis testing. After hypothesis testing, we have discussed about type 1 and type 2 error. And after moving through the type 1 and type 2 error, we have started with the types of test. Okay. Types of hypothesis statistical test which are available. And they were T test, F test, C test, chi-square test, ANOVA. So we're done with the T test. So let me just share the screen of my notepad. Okay. Just a moment. Okay. So t-test. So what is the main purpose of the t-test? To compare the mean and determine if there are any differences. Okay. And there are even types also. One sample t-test. One sample t-test is nothing but comparing the sample mean to a known population mean. And also there is this independent two sample test. What exactly it does? It will compare the mean of the two independent groups. Okay. And we're having this paid t-test. Paid t-test will compare the mean of the same groups at different times. Okay. Same groups at different times. And when to use this exactly? Now I'll just write it over here. Okay. When to use the t-test? So we need to make sure that our sample size is, what should be our sample size? It should be less than 30, right? So we'll be defining sample size as n. So n less than 30. Okay. So that is one. And also the population, whatever the population we're having, that standard deviation should be unknown. Okay. Should be unknown. Unknown also. And one, what is another thing? It should be normally distributed, right? The data should be approx normally distributed. Okay. So these are all the three main factors we need to consider when we are able to do a t-test. Okay. When we are able to do a t-test, these are the three main factors we need to consider. So this is about the t-test. Okay, this is about the t-test, and one of the example you can consider is comparing the average test scores, whatever the assignment or the test which has been conducted in our during our college days or during our school time. Okay, comparing the average test like before attending a particular workshop or else. Okay, okay, fine. So comparing the average test scores of the students. Okay, like before attending a workshop or else after attending a workshop, before and after attending, how the average test score of each and every student is. Okay, and then we will be comparing those scores. Okay, so that is one kind of an example. And then we'll move into this z test. Okay, z test. So what exactly is the z test? Z test is to determine whether the sample mean is different from the population value. Okay, it is mainly to determine whether the sample mean or the proportion differs from the known population value. Whatever the known population value which we are having, if it is different from the sample mean or not, to determine that, we'll do the z test. Okay, this is a sample mean different from a known population value. In this scenario, we'll do the z test. Okay, in this scenario, we'll do the z test, and in this z test also we are having types. So first one is one sample and two sample, and also we are having z test for proportions also. If you want to do compare the sample and the population in a specific proportions, then we can do the z test for proportion also. In this one sample and two sample, what we'll be doing? One sample means comparing a sample mean with a sample population. Okay, compare sample mean with population mean. Okay, pop mean is nothing but population mean. Okay, so in two sample, what we'll do in two sample, it's again comparing two sample means only. Compared to sample means. Okay, compared to sample means. And when to use this z test again? When to use the z test? When the sample size is greater than 30. Okay, so sample size is n. So in that case, n should be greater than 30 in order to use the z test. Okay, not to use the z test. And here also it will be the same. The population standard deviation will be unknown. So then only we can do the z test. So one example what you can consider for the z test is, I hope my voice is audible, right? Yeah, okay. So the one example that we can consider for z test is like like checking the average delivery time of an e-commerce company. Okay, so let's say there is this Flipkart. Okay, checking their average delivery time. If they were promising like within express delivery like 2 days, and what is their average delivery time? Is it different from any promised time? So that is what exactly, I mean, in those kind of scenarios, we'll do the Z test, where we'll have the population mean, we'll have the sample mean. In two different ways, we can do the testing, one sample and the two sample. Okay. And then moving into the F test. Okay. We'll discuss the F test and then we'll go with the ANOVA and the chi-square. Chi-square is for categorical data. Okay. I'll just finish off this test only. So if anyone is having any doubts in between, you may ask me. Okay. So here what we'll be doing in F test is the variance. Okay. Variance we'll be measuring the variance over here in the F test. Understood, right? What is variance? Everyone knows, right? We'll measure the variance over here in the F test. Let me just write here. We'll measure the variance. Variance is nothing but measuring how spread out the numbers are in the data set, okay? The numbers are in data set, okay? So in this F test also, so it's like it will tell us how far each number is from the average, okay? Each number is from the average value, or else if the numbers are close to the mean, if the numbers are very close to the mean, then the variance is small, okay? And if the numbers are more spread out, the variance is large, we'll say. Okay. So the example you can consider for this F test is like the students' test marks again. If everyone is around 80 and 80, then the variance will be very low. And if the students, some are scoring around 50 and some are scoring around 170, the variance will be high, right? When compared with 50 and 70, the variance will be high. Yeah. And what exactly variance? So this is about the variance. And now in the F test, what exactly we'll do is we'll compare the variances of the two sample groups. Okay. Two sample groups in the F test. And what exactly variance is? How spread out the numbers is. Okay. We'll measure the variance. Measure the variance. Fine. So when to use this variance before performing a t-test or an ANOVA test? Okay. Before performing a t-test or ANOVA test, we can use, or else to check the equality of the variance also we can do the F test. Okay. Equality of the variance also we can do the F test. And then comes the ANOVA test. So what exactly is ANOVA now? ANOVA is nothing but ANOVA. The name itself is analysis of variance. Okay, analysis of variance. ANOVA is nothing but analysis of variance. So what is ANOVA? The main purpose of ANOVA is to compare the means of 3 or more groups. Okay. Compare the mean of 3 or more groups. Okay. So this is what ANOVA does. In this also we are having types. The types are one-way, a one-way ANOVA test, and also two-way ANOVA test. Okay. One-way is nothing but we'll consider only one independent variable. Two-way means we'll consider two independent variables. Okay. Two independent variables, and the formula to calculate this ANOVA is, yeah, we can write this formula. So it will be like let's say f is equals to, it will be mean square between the groups. Okay. Mean square between the groups by mean square within the groups. Okay. Mean square within the groups. Okay. Between the group and also within the group, we'll be calculating the mean. Okay. Mean square between the groups and mean square between the within the groups. So whatever the groups that we are considering, on those groups we'll be performing that mean square and we'll be calculating the ANOVA. Okay. We'll be analyzing the variance. And when to use this ANOVA? To test if at least one group mean is different from others or not. Okay. Let's say there is a whole data set and we're considering groups. So if you are doing a two-way, we'll consider two independent variables over there. Two independent variables means two independent columns we'll consider. Okay. What exactly independent and dependent we'll see in the next 5 to 10 minutes. Okay. So when to use this ANOVA exactly? To test at least if one group mean is different from others. Okay. One group mean is different from others. Okay, and chi-square is remaining, right? So chi-square test is nothing but what exactly it will be working on a categorical kind of a data. Okay, it will be working on a categorical kind of data, and what exactly the main purpose is to compare the observed and the expected frequencies. Okay, expected frequencies for the categorical variables. So one of the example that you can consider is like the choice of preference. We'll be dealing with the social media platforms, right? So when we want to get to know about the relationship between any two columns, like is there any choice preferred by the persons in the category of this social media, then in those kind of scenarios, what is observed and what is expected over there? What kind of scenario is expected over there? What kind of action is expected over there? So in those kind of scenarios, in those kind of categorical distribution, we'll be going for this chi-square test. Okay. Here, the main important key terminologies in chi-square test is observed frequency and the expected frequency. Okay, observed and the expected frequency. So these are just the statistical test. Just go through. Okay. No data is spread in the dataset may be in any sequence. I see one query. So how we know how the data is spread in the dataset? See, we'll be calculating it through variance. Okay, we'll be calculating it through the variance. Through the variance only, we'll be measuring the data and we'll be getting to know how each and every first will be based on the average only. We'll be calculating how each and every data point is it near to the mean or else is it very far away from the mean. We'll be calculating. Okay, it should not be widespread. The variance should not be large. The variance should be low in order to make sure that our data set is a normally distributed. Okay. Okay, fine. So these are about the all the statistical test. Okay, now we'll be discussing about the machine learning life cycle. Okay, machine learning life cycle. Anyone know the life cycle steps? Anyone aware of it? Or else, what are all the algorithms that you are aware of it? Okay, just type algorithms. What are all the algorithms that you have heard of? Machine learning algorithms that you have heard of. Okay, first one I see K means. Okay, okay, linear regression, naive Bayes. Okay, naive Bayes and also okay, KNN. Fine. Any more? Logistic regression. Logistic regression, yeah, random forest decision tree. Correct, okay. Random forest. Okay, fine. So, okay, CNN is a deep learning algorithm, okay. CNN is convolutional neural network. It is a deep learning algorithm. So these are some of the machine learning algorithms. Even there were other algorithms also, but these are all you people know. Correct. These are all you people know. So now, first we'll define. First, I will write down all the machine learning life cycle steps. Okay, I will write down all the machine learning life cycle steps, and here we are starting with the actual machine learning. Okay, so I want everyone to keep your focus over here. And if anyone is new to this session also, this is what you are here for, okay? So please try to understand. Even the other sessions are also important, the previous sessions. But please make sure you are understanding this, okay? Okay, machine learning life cycle. Now we'll discuss the machine learning life cycle step. First, initially, what we need to do is, first I will write down the steps. Or else, yeah, not right now, not right now. Okay, let me just give you the small difference between this independent and dependent variables, okay? First, what is machine learning, guys? What is machine learning? We will be telling, or else we will be training an algorithm, or an algorithm, and we will be making sure that that algorithm is learning all the relationships or else all the patterns present in our data, and then it will be able to do the prediction, right? It will be doing the predictions on the unseen data, correct? On the unseen data. So in the machine learning also we are having types. In the machine learning also, the machine learning we are having types, okay? So what is the first one? The first one is supervised, okay? First one is supervised machine learning, and the second one is unsupervised machine learning. Unsupervised machine learning, and the third one is the reinforcement machine learning, okay? So reinforcement machine learning. So what exactly is a supervised machine learning? What exactly is an unsupervised machine learning? What exactly is a reinforcement machine learning? Now we will see, okay? I see few people are updating the definitions also. Yeah, it is a subset of artificial intelligence, correct? Fine. Okay, fine. So what exactly is supervised machine learning now? Supervised machine learning is here we'll be having the labeled data, okay? We'll have the labeled data and we will tell the model to learn on the labeled data, okay? Learn on the labeled data and predict on the unseen data, okay? Unseen data. So this in the supervised learning, what exactly happens? We'll tell the model to learn on the label data and predict on the unseen data. Learning on the label data means, what is labeled data? Label data means, in the sense, it's like where it will have both the things. What are those both things? It will have a independent columns and dependent columns, okay? Dependent column is also called as a target column, okay? Dependent column is also called as target column, okay? In the supervised learning, we'll have the labeled data. Labeled data in the sense rows and columns again. Rows and columns, where in those columns, there is a difference. We'll have both independent columns and a dependent column. So what are these independent columns and dependent columns? First, we'll be starting with the supervised learning, okay? What are these independent columns and a dependent column? See, we can also call them as features, variables, okay? We can call them as features or the variables also. Fine. Or as independent features, let me say it as columns. Let me just keep those columns in the bracket and let me call it as features, okay? Features. Independent features and dependent features. So what is this independent and dependent features? How exactly do we need to identify an independent feature and a dependent feature? Okay. Now we will be discussing about this independent features and dependent feature. Now any one of you can show me any can tell me any domain. I'll just share my OneNote. Okay, I'm sharing my entire screen now, so even you people can see the responses, correct? So independent features, age, room, kitchen size, condition. So one of the option or else one of the domain one of your friend is suggesting is house price prediction. House price prediction. So now the target or dependent, yeah, it will be the price of the house. Fine. Okay, you're just saying the answer. I thought that you are suggesting a domain. Fine. Okay, now let's consider the domain of ice cream. Okay, sales. The domain is sales, and here we'll discuss about the ice cream. Okay, ice cream, ice cream. Okay, so let's say I'm having a data set. Okay, I'm having a data set where the data set columns are first, as usually we'll be having a the ice cream name, correct? Ice cream name. Okay, what are the other columns I can consider? So ice cream name means in the sense, is it vanilla? Is it butterscotch, chocolate? Okay, and the brand of an ice cream. So what exactly brand is? Oh, you can consider Arun, and you can consider NIC, Naturals. You can consider. There are many brands, right? Even in the ice cream also. Fine. So ice cream name, brand, and what else you can consider? What are the other factors you can consider? Season or else a month you can consider, right? Now we are doing a sales, right? The domain is sales. So we can consider the month over here also. Month, not month exactly, or else let me just keep the price over here. Let me just do the price. So these are the three columns I'm having, okay? These are the three columns I'm having. So let's say 20, now 30, 40. And again in the vanilla flavor, I'm having for Arun also. I don't know why, but they were charging here 50 now. I mean, this is just assumption, okay? It is not real, and it depends also. Okay, so but Ibeco is charging only 25. Now I need a. Let me just keep a chocolate over here. Okay, so I'm having 4 rows, 3 columns. What is the shape of this particular data set? 4 rows and 3 columns. What are the 3 columns I'm having? Ice cream name, the brand, and also the price. Correct. So now so now I need to consider. Now I need to understand what is the problem statement that I'm trying to solve. Why I have been provided with this data set. Okay. See, let's say you are working in a company and your manager calls you and he'll be telling you that so there is one problem. We need to resolve that and you need to resolve it with machine learning algorithms only. So this is the data set. So just try to come up with a machine learning model. He'll be saying. So now what you need to do is you need to figure out, is machine learning model really necessary over here? First thing. And what is the problem that your boss is facing or else your company is facing? Okay. You need to figure out in those perspectives first. So what is this? It is related to some ice cream name, brand and price we are having. So it is related to the ice cream data where if we can do the sales or else just by giving the brand name, ice cream and also price, we can get to know the details of that particular brand and the ice cream also. So we are trying to do the price prediction over here. Okay. And how did I get to that conclusion? How did I get to the conclusion that we are doing a price prediction? By looking at the ice cream name and the brand. See, The name, it will be completely independent. Okay, the name is independent. If you see, vanilla means it could be belonging to any brand, right? It could be belonging to any brand. It could be a different brand, that is a naturals also. Even the butterscotch, it could be a different brand also. Correct. So these are just the flavors which are independent to each other. Okay, which are independent to each other and also independent to other columns also. They were not dependent on any column. If you see, if you just see only this ice cream name, so we'll just see vanilla, uh, butterscotch, chocolate, and also again vanilla again. So we'll just say they were just the ice cream flavors. Correct. It could be of any brand. So they were just the independent names, independent column. So we'll consider this as an independent column. Okay. And coming into brand, what is brand here? Ibaco, Arun, NIC, and Arun. So, and we all know that these are all the independent branches which sell different types of ice cream. So, even these columns are independent of each other. Okay. So, we'll consider this column is also independent column. But if you see the price, sorry, where was that? Okay. If you see the price column over here, it is 20, it is 30, it is 40, it is 50. What is 50, what is 40, what is 30, and what is 20? So we are not understanding. If you consider only single column and see what is 20, what is 30, what is 40, and what is 50. They were just numbers. But how did we get those numbers? Then we'll start looking for the other columns. Are these numbers dependent on these columns? Okay, 20 Ibaco. Ibaco, it is saying 20. For Arun, it is saying 30. For NIC, it is saying 40. For Arun, it is saying 50. So these are all the ice cream brands. So are these prices related to those ice creams? Let's check with the other column. So in the Ibaco, there is this vanilla and it is saying 20. So now there is a meaning for this 20. Correct. Now there is a meaning for this 20. And for Arun, there is this butterscotch and it is saying 30. So price for this butterscotch flavored in the Arun brand, it is 30. Fine. In the NIC brand, there is this chocolate which is costing 40. Okay, this is also fine. Now we understood 20, 30, 40, 50, right? So all these columns, all these, this one single column, is completely, how did you understand this? By comparing with the other columns, right? But comparing with this column and this column, you understood what is this P column. So now you will call this P column as a dependent column, okay? Sorry. Dependent column. The P column will be a dependent column, and these two columns will be independent, okay? Independent columns. So hope you people understood the difference between a dependent and an independent column. Any doubts, anyone? I'll just stop the screen. Now, if you're having any doubts, let me know. So, Shivam, the space you're typing, right? Can't access the chat section. That is what the chat section is, okay? Okay, Vadilal, fine. I'm sorry I missed that. Okay, Ben and Jerry, fine. Available numbers, price of the ice cream. So, did you understand what exactly the price of the ice cream doing over there? And what is a dependent and an independent column? Understood the difference, everyone? Just a moment. If anyone is having any doubts, let me know. So anyone, any doubts? No, right? Yes, price is dependent on the brand and the type. So even you can consider any other domain also. See, in the next few minutes, we'll be having a short break, right? So in the short break, I'll just give an assignment for you. So in that 10 minutes time period, just think, okay? Just don't choose the Google or else any other ChatGPT or Gemini. Just think of any brand, come up with the columns, come up with all the columns, and you need to decide which are the independent and which are the dependent columns. Okay, try to think it off, so you will be understanding what exactly the difference between independent and dependent columns. Okay, understood everyone? Okay, fine. So Keshav and Rajveer, you didn't understand what exactly the difference between a dependent and independent column, or else have you understood? Okay, fine. I'm not seeing any responses, so fine. I'll just proceed for now. I'll just proceed for now, and let me just share the screen. So now in the supervised learning, we'll have the labeled data, right? So labeled data is nothing but the model will be training on this labeled data and it will be predicting on the unseen data. So what is the labeled data here? It is nothing but the independent features and the dependent features. Okay. And one more thing. Okay. One more thing. Target column, right? So how is the price column over there? Price column is numerical, right? Price column is numerical. So we will call it as a regression problem. Okay. Regression problem. And if the target column is like if you're trying to predict the brand of an ice cream, okay, we're having the price and we're having the ice cream flavor also, and we're trying to predict the brand of an ice cream, then brand of ice cream, then that kind of problem will be what is the data type? It will be object, right? The data type will be object. Object in the sense it is a categorical data. Categorical data. Okay. Categorical data means what kind of problem it is? It is a classification problem. Okay. Classification problem. So in the supervised learning, we'll have two types. Okay, in the supervised learning, we'll have two types. One is regression and one is classification. Okay, let me just a moment. Okay, fine. And here I can say there is this regression and classification. Okay, so this is about learn on the label data and predict the unseen data. We'll have the regression and classification type. And to understand regression and classification, we need to understand the difference between independent features and the dependent features. Okay. So when the target column is numerical, it will be regression. When the target column is categorical, it will be classification. Okay, regression or classification, it completely depends on the target column. Okay, let me just write here. When target column is numerical, it is regression problem. When it is categorical, it will be classification, right? It will be a classification problem. So understood the difference between a regression and a classification? Understood the difference between a regression and a classification? In the supervised learning, again, we'll have two types of problem solving, regression way and a classification way. And when to use a regression and when to use a classification, it will depend on the target column. Okay. Okay, fine. So if anyone is having any doubts for this supervised learning, it is fine for now. Okay, we'll explore more further. Okay. And Ayush, please reframe your question. I didn't understand your question. Okay. So now coming into unsupervised learning. Okay, unsupervised learning, here will not have any labeled data. Here data will be unlabeled. Okay, unlabeled data. So every column, unlabeled data in the sense every column will be acting as an independent columns. Okay, there will be no dependent column over here. Every column will act or seem like an independent column only. Independent column. Okay. So in unsupervised learning, how we will make sure that the model is learning? It will learn based on the patterns. It will learn based on the relationships between the columns. Okay. That is about unsupervised learning. It will be on the unlabeled data. And again, it will test on the unseen data only. Okay. Unseen data only, it will be testing. It will train on unlabeled data and test on the unseen data. Okay. And coming into reinforcement learning. Reinforcement learning, the best example we can consider is so before going into example, how it works, it will work on a reward based system. Okay. Reward based system. Reinforcement learning will work based on a reward based system. Yeah, both regression and classification will come under this supervised learning. Okay. So reward based system, what is the example you can consider for this? So when you are using ChatGPT, you'll be getting the responses, correct? So sometimes what happens, suddenly you'll be getting two different responses, response 1 and response 2. And then ChatGPT will be asking you to prefer any one of the response, correct? So based upon the explanation, you'll be choosing either response 1 or response 2, correct? Either response 1 or response 2 you will be considering. So, and then if you observe for the next few questions, the explanation or is the response will be in the similar format, whatever the response that you have chosen. Then whatever the response that you have not chosen, you will be not getting those kind of responses. You will be getting only the response type or the preferred response that you have selected. In a similar manner or in a similar pattern, you will be getting the responses. Have you observed it? So that is what a reinforcement learning is. So now what exactly happens in the reinforcement learning? In if, for example, if you're selecting response 2, okay, so response 1 which it has generated, it for that response it will be penalized. Okay, the model will be penalized, and for the response to which you have selected, it will be rewarded. Okay, it will be rewarded, and so the model will be working based on the reward based system. So if it is rewarded, so model will try to generate the responses in those kind of formats only. Okay, in those kind of formats only. So these are the differences between a supervised learning, unsupervised learning, and reinforcement learning. Okay, reinforcement learning. And machine learning means all these three learnings: supervised, unsupervised, and reinforcement learning. So we'll be discussing about this supervised and unsupervised learning. Okay, and whatever the algorithm that you have told, that is a mix of both supervised and unsupervised learning. So we'll see how to deal with this missing values, duplicates, up to heat map. Okay, up to heat map will consider each and everything, whatever the machine learning workflow life cycle which involves, and then in the model building the things will be different. Okay, so we'll just have a short break now. We'll just have a short break, and after that we'll be discussing about this machine learning life cycle. Okay, yes, it is a trial and error through rewards. Okay. Okay, so basically we don't know how we are moving towards a final. So Ayush, these kind of questions you need to ask in the AMA session. Okay, if you want to know about that particular workspace or the dashboard and how to work on the project, you need to discuss all those topics in the AMA session. Okay, as you have already enrolled in the project, I see. Is that clear, Ayush? Okay, fine. So I see a few other queries also related to reinforcement learning. So trial and error through rewards, yes. What is the meaning here of reward? Okay, fine. What kind of penalty or reward will the model get? Okay, fine. So it's like based on the actions or the outcome of this action, we'll be rewarding the model. Okay. So the rewards will be like the positive reward and the negative reward. So if it is a positive reward, then it's like we are rewarding that particular model, and if it is a negative, we are penalizing the model. Okay, penalizing the model. It's like a feedback. It's like we providing a feedback to the model. So how will unsupervised machine learning be working? So unsupervised machine learning, it's like it will learn through the patterns. Okay, it will learn the patterns and understand the relationships between the columns. It will learn the patterns, how the patterns are being formed, how each and every column are related to in that particular sector. I'll give an example. Okay, I'll give an example of this unsupervised learning. There is a good example. Okay. So for now, remember the work which I have given you. Try to think of few columns in the supervised learning. Try to think of few columns of any domain and distinguish between the independent and the dependent columns. Okay, fine. So let's have a short break now. And if anyone is having any other doubts, you may ask me. Rishabh, Jayendra, also Parikshit, Ayush. Okay, thank you. So the question is, firstly the question is, see, I want you to consider a domain of your choice. So in the domain, consider few columns. Okay, consider few columns and try to distinguish between what should be the independent columns and what is a dependent column. Okay, try to gather few columns as per the domain knowledge you're having, and now try to think which columns comes under independent and what column comes under dependent. Okay, that is what the assignment which I have given for the next 10 minutes. Okay, fine. So please continue with your assignment, that is in the short break. So please try to think in the meantime. Please take a short break for 5 minutes, and in the next 10 minutes, that is your assignment. Okay, so I want everyone to be back here by 7:15. Okay, fine. At 7:10 or else at 7:05, be back here. So from 7:05 to 7:15, try to think of a solution or else try to think in that perspective. If you're having any doubts on any domain, you may ask me in the Q&A also. Okay, okay, fine. Thank you. Okay, fine. I hope everyone is back from the break, and I also see many answers. Okay, so one of the domain is electricity, and I see another domain is about this mobile industry. Okay, and one of the example was related to the student performance. Okay, okay, healthcare domain, home loans. Okay, fine. So everyone got the idea, right? What exactly, how to identify the independent and the dependent variables. Correct. Everyone got an idea, right? Fine. So still anyone, any doubts? No, right? Okay, fine. So now we'll discuss about the machine learning life cycle steps involved. Okay, machine learning life cycle steps involved. Just a moment. Let me just share this. So first, the machine learning life cycle step. So what is the very first step in the machine learning life cycle? The very first step is defining the problem statement. Okay, define the problem statement. So what is our problem statement? Understanding the problem statement. The very first step in the machine learning. Okay, the very first step in the machine learning is understanding what kind of problem that we're trying to dealing with, what kind of domain that particular problem is with. Problem. Okay, the type of the data also we can consider what kind of data we are dealing with. Okay, and the next steps involves the data collection or the data gathering. Data gathering or data collection. Okay, this is the next main major step, and after this comes the pre-processing. Okay, data pre-processing, and then the model selection, then the model selection, then comes the splitting the data, split the data, and after splitting the data, what are all the things we'll be doing? Training the model. Okay, after training the model, what is that we'll be doing after training the model? We'll be evaluating that model, right? Evaluating the model. And after evaluating the model, what we'll do? After evaluating the model, we will test the model. Okay, test the model, and then if any hyperparameter tuning is required, we'll do the hyperparameter tuning, or else we will deploy the model. Okay, hyperparameter tuning, then deploy the model. Okay, fine. So these are all the major steps which are involved in the machine learning lifecycle. Okay, defining the model, defining the problem statement. So first what we'll be doing is we'll be defining the problem statement. What is this problem statement and what is this domain and type of the data? After splitting the data, we'll build the model. Building the model is nothing but train the model. Okay, build or train the model. Build or train the model. Okay, fine. The very first major step is very important. It is defining the problem statement. We will define what kind of problem statement that we're trying to solve, or else what kind of problem that we're trying to resolve, and what kind of domain that we are working. We'll understand the domain first, then we will understand our data. Okay, and then after understanding the data, we'll be making sure for this kind of problem what kind of solution we can come up with. Is it okay to go with the machine learning, or else is there any other solutions? Okay, then we'll go with the machine learning. So up to data collection, you'll be already having the data, right? You'll be already having the data. You'll be just directly provided with the data. So based on the data, you'll be deciding. So what are all the steps which are involved in this after data collection? Pre-processing, selection, splitting the data, building or training the model, evaluating the model, testing the model, hyperparameter tuning if required, and deploying the model. So what happens in the after, what exactly happens after data collection? Okay, after we have collected the data, what exactly happens? What is this data pre-processing and model selection? We'll see. Okay. So what are all the steps involved in the data pre-processing? Reading the data. We'll read the data. How we'll read the data? We'll use the pandas library, right? pd.read underscore CSV, correct? So if it is a CSV, we'll use CSV. If it is a Excel, we'll use Excel, or else if it is a JSON, we'll use JSON, right? And after reading the data, what are all the 5 major steps that we'll be doing? After reading our data, what are the 5 major important steps that we'll be doing? I told you, right? While discussing the pandas, we have also performed that. Okay, check for the null values first. Okay. Duplicates, okay. So after reading the data, what we'll be doing is we will check the info, right? We'll check the information. We'll check the shape. We'll describe the data if there were any numerical columns. And what we will do, then we'll check for the null values. And also we'll check for the duplicates. Okay, duplicates also we'll check. So then comes the important thing, outliers. We will deal with the outliers if any. And how we'll find the outliers? We'll find the outliers by doing the EDA process. We'll perform the exploratory data analysis. Data analysis, and by performing the exploratory data analysis, we'll get to know the outliers, and by these outliers only, or else we'll get to know how our data is being distributed. Now we'll discuss about this EDA part. Okay, what exactly is EDA? We'll discuss. Did we discuss about EDA? See, outliers is nothing but the data points which are lying far away from our own data, or far away from our all the data points. Okay. Did we discuss EDA? Or are you people aware of EDA? Okay, I see no response, then fine. So exploratory data analysis means we will consider the features. Okay, we'll consider the features. Okay. We'll consider the features. Features are nothing but the columns again. Okay. Features are nothing but the columns. So we'll consider the columns, and then we will explore those columns. Okay. We will explore the columns, explore them, or else let me just write over here. Explore the features and explore the features, and then we'll do the analysis. By exploring those features, we'll do the analysis and come to a conclusion by drawing the insights and draw insights. Okay, we'll draw the insights. What exploratory data analysis is for? We'll consider all the columns which are present in our data set, and on each and every column we'll do the analysis. How we'll be doing the analysis? We'll be exploring the column and we'll do the analysis and we'll draw the insights. And how exactly we'll do that? We will do that exactly through two libraries, that is matplotlib and Seaborn library. Okay, matplotlib and Seaborn library. By using these two libraries, we'll be doing this exploratory data analysis. And what are these two libraries? What are these two libraries? They're used for the plots, right? For plotting, correct. For visualization. Okay. And through the visualization only, we'll be drawing the insights. In this exploratory data analysis also, we are having three types. Okay, three types we are having. One is univariate, bivariate, and multivariate. Okay, these are the three different types which are present in the exploratory data analysis. Okay, in the exploratory data analysis, we are having univariate, bivariate, and multivariate. Okay, what is univariate? Univariate is nothing but we'll consider only single column. Okay, single column or feature, and we'll do the analysis on that single column or feature. Okay, and what kind of plots which are suitable for this univariate analysis? We'll discuss that. Okay, plots suitable plots. Okay, and in the bivariate analysis, what we'll do, bi means two, right? So we'll consider two columns. So two columns are features. And in multivariate analysis, what we'll be doing, we'll consider three or more than three columns. Okay, more than three columns, and then we'll be doing the analysis. Okay, so what are the suitable plots for bivariate and multivariate? Depending on the columns we are considering, we'll be switching the plots. Okay, but in the univariate, what are the some suitable plots you can consider is, let's say if you are working on a categorical variable which is having around 3 to 4 values. Okay, categorical variable which is having around 3 to 4 values, and in order to do analyze those columns, we can use a pie chart over there. Why pie chart? Because as it is a categorical column, we can check the proportion over there, proportion and the distribution of those values over there. Correct, values over there. So you can, some of the plots you can consider for this is for the distribution also you can consider the bar chart. Correct. So there were like many suitable plots for this. So not any specific plot I can say. many suitable plots depending upon the type of the column that we are considering. Okay, considering, and there is one main plot, that is box plot. Okay, box plot is suitable for finding out the outliers. Okay, what is outliers again? Outliers are nothing but the data point which is lying far away from the other data points. Okay, data point which is very far away from the other data points. Okay, so not right now. I'll show the implementation of all these univariate, bivariate, box plot, outliers, and each and everything which we are discussing from today will be having an implementation also. Okay, don't worry. Okay, coming into this box plots, outliers, fine. Okay. Yeah, box plots are mainly for outliers. Okay, remember this. Okay, so this is pretty much about this EDA. Okay, this is pretty much about this EDA. Mostly EDA you can do when you're working on any project, and if you want to draw the insights, a data analyst will be working more related to this EDA part. Okay. Okay, fine. So where are we? So here we are, right? So data pre-processing. Here we are. Reading the data, getting to know the information, the shape, then describing the data if there were any numerical values, how the mean and the other values are, and about the null values, duplicates, and exploring the data by by the exploratory data analysis. And here in the exploring the data, what we can find about the outliers. And after dealing with the outliers, what we'll be doing is, after dealing with this, we'll make sure that our data is being normally distributed. Okay, we make sure data is normally distributed, and then what we'll be doing, there is another step also, that is called as feature engineering. Okay, feature engineering. Unheard of feature engineering? See, in the feature engineering, there are two ways of feature engineering. Okay, two ways of feature engineering. Okay, so let's say in the feature engineering, let me just write here. So now I'm having a column called as date. Okay, date, I'm having a column, and the format is year, month, and date. Okay, year, month, and date. So now let's say I just want to do only what kind of analysis? I want to do only monthly data analysis. Okay, I want to work on only month data analysis. So now what I will be doing, let me just write it in the OneNote. Okay, okay, I hope everyone is able to see the OneNote also. So in the feature engineering we are discussing. Okay, feature engineering, ENGG, fine. So in the feature engineering, I'm having few columns. In that, one of the column is date column. Okay, date column. So this date column, how it is having, it is having in the format of year, month, and date. Okay, year, month, and date in one single column. So how the values will be 1990, 12, 21. It will be in this format, right? So I'm having other columns also. I'm having extra other columns also. I want to do I want to do what? My problem is to do a monthly sales prediction or else monthly sales data analysis. So monthly analysis only I need to do. Monthly. Okay. Now what I will be doing is, I don't want year, I don't want date, right? I want month. So what is the best way to do? What I will do is I will just import the date time index library. Okay. There's a library called date time index. This library, and I will be dividing that. I'll be dividing whole date, which is in year, month, and day format, to only how it will be divided means I will have, this is one single column. Okay. Now it will be divided into 3 columns: year, month, date. So total I'm having extra 3 columns. I will have this date column. Along with the date column, I'll have year, month, and day. What is my problem? My problem is to get the month analysis, right? Month. So what I will do, I will drop the date, I will drop the year, I'll drop the day. Correct. So day and year are the extra columns. Extra columns created, right? And this date is the pre-existing column which is in this format, year, month, and date. So this is the extra column which I am keeping. I'm dropping are the other columns. Okay. I'm wrapping the other columns. So month is the column I'll consider, and I will drop the other columns. So that is one kind of feature engineering. That is one kind of feature engineering. Okay. Understood? Understood this kind of feature engineering step? So it's like we are dividing that whole column into multiple columns and then considering the column which we want and then dropping the other irrelevant columns. Okay. Is that clear? That is one of the feature engineering step. Feature engineering, the name itself it is saying feature is nothing but the column. We are engineering that column. That's it. So there is another way of feature engineering also. There is a different way of, I'll just say another example also. So what did we do in the first example? We have divided that particular column and then we have considered the column which we want. So in this kind of feature engineering, what we will do is, let's say the data set is related to a health domain. I'm having the weight. Okay, the weight I'm having, the height I'm having, okay, the weight, height, and also I'm having what I'm having some other columns like gender and some name and ID. So let me consider these 3 columns. Okay, weight, height, gender, and other columns like some other columns I'm having. Okay, so let's focus on weight and height. So the weight and height relationship will be almost very close. Okay, how, anyone know about this term BMI, body mass index, and how the body mass index is calculated? The body mass index is calculated based on the weight and the height of the person, right? Based on the weight and height of the person. So I'm already having this weight and height. Okay. So instead of keeping these 2 columns, I can directly calculate BMI. Okay, I can directly calculate BMI and add another column here as BMI and keep the values over here, right? And then I'll drop these 2 columns. I'll drop weight and height. After the BMI is created, I will drop weight and height. So that is one way of feature engineering. Okay. Understood? Understood feature engineering? Yeah, weight and height. Yeah. Yeah, but what are we doing? Let's say I'm having that BMI column also. Will I keep that height and weight? No, right? I'll just drop it, right? But how I'm understanding that BMI will be calculated based on weight and height. I'm understanding how I'm understanding because in the previous steps I will understand the domain, right? I will understand the domain. So that is the way. That is the only way. If you understand the domain only, you'll be understanding which columns you can feature engineer, which columns are okay to continue further. Okay. Weight and height only will be calculate the BMI. Fine. So everyone understood, right? BMI? Any doubts? Any doubts on feature engineering? Anyone? No, fine. Thank you. Okay. Thank you, fine. Okay, so let me just share the notepad screen once again. So feature engineering is done. So after feature engineering, there is another step. So ever heard of label encoding? Label encoding. Label encoding, okay? Label encoding. So what exactly the thing we do in label encoding? Okay, few people heard, few people haven't heard. Fine. So in the label encoding, I will just explain about this label encoding and also okay, we'll just stop here up to label encoding. There is another step called as normalizing our data. Okay, standard scaling our data. Okay, scaling the data. There is another step, and after scaling the data, there is this correlation also which is involved. Correlation, and then after correlation, then we'll go for the model selection. Fine. So we'll discuss label encoding and we'll end the session for today. So what is label encoding? Label encoding. Label encoding. So what will be the labels here? So in the data set, we'll have two different kind of values. One is categorical, one is numerical, right? One is categorical and one is numerical. So for these two different columns, the model needs to understand these two different values. So what we'll be doing is, see how the computers will be understanding the data. I mean, how it will be understood. It will be understanding the things in a 0-1 binary format only, right? So we will, in the label encoding, what we'll be doing is we will be converting the categorical columns, okay? Categorical columns conversion will be happening. Convert how we'll be converting by labels and encoding the labels, okay? By encoding the labels or else by label encoding. Encoding, how we'll do the encoding? So let's say I'm having a brand of an ice cream column, okay? So in the brand of an ice cream column, I'm having only three values. What are those three values? Let's consider our own NIC and naturals, okay? Our own NIC and naturals, fine. So how these values will be encoded? So whatever the value which is having more number of records will be encoded as 0. And the values which are having in the like in an ascending format, it will be encoded 0, 1, 2. Okay, 0, 1, 2. So let's say if Arun is having more number of records or observations, then it will be 0. then followed by NIC. In that case, NIC will be 1, naturals will be 2. Okay, 0, 1, 2 will be the label encoding process. Okay, 0, 1, 2. Okay, 0, 1, and 2 will be the label encoding formats. Understood label encoding? Understood label encoding? So now let me know. I had just created a small poll. Let me know, okay? I see 1 no. So what was the topic you haven't understood? I see 2 no's. So what was the topic you haven't understood? You may let me know in the Q&A, okay? Okay, explain label encoding once again. Fine. So what is the other no for? I got 5 no's, okay? I got 5 no's. So I'm expecting 5 questions from, if it is from the, yeah, from different persons, correct? So I'm expecting 5 different questions. I see only 2 questions as of now. Label encoding, explain them once again. Fine, I will explain. So Akash, just a moment, Akash. Let me just explain this label encoding, and we'll go with this. We'll go with your query. Okay, just a moment. Okay. Label encoding. What is this label encoding? So in the brand of an ice cream, okay, let's consider the column brand of ice cream. Okay, ice cream. This is the column. So let's consider 3 values. Okay, let's consider 3 values. First value is Arun, and let's consider NIC, and let's consider Ibaco. It's easy to write. Ibaco, okay, or Ibaco, I think is fine. So now let's say I'm having Arun of around 50 rows. I'm having for Arun, okay, 50 rows I'm having for Arun, and around 20 rows for NIC, and Ibaco I'm having 30 rows, okay, 30 rows. So now Arun will be labeled as 0, okay, and Ibaco will be labeled as 1, and NIC will be labeled as 2, okay. As indexing starts from 0, so this is how we are encoding this label. So this is the label here, this is the label, this is the label, and what are we doing? We are encoding this label as 0, this label as numerical, this label as a number. Why we are encoding them as numbers? Because the model will be understanding only the numerical values, okay. And but how we are encoding it as 1, 2, or 0? Why can't Arun be 1? Because whatever the Arun is having around highest number of rows, that is 50, so I have given it the first place, and NIC is having 20 values, so it is the second place. So sorry, yeah, it is the second place, and Ibaco is having 30, so it is first place, okay. 0, 1, 2 index format, okay. index format. Understood? Any doubts? Understood, Sahu and also Vidushi. Okay. They won't lose their identity, okay? If you are having more in number, that is a different scenario. But most of the categorical variables will be like in between up to 3, 4 or up to 5 values only we'll be having if you observe. Yes, it will assign the numbers. And Akash, you were asking about this notepad, right? So instead of notepad, it's better in the handouts only because notepad it will be very clumsy. You won't be understanding exactly what exactly it is related to. Each and everything will be line by line. I can explain you by showing the PPTs also, but in this way it will be very interactive. I thought. I think. So that is the reason I'm explaining in the notepad. There is no other reason, okay? And if you want me to switch to PPT, I will just switch to PPT. Okay, standard deviation of categorical variables like brand and flavor will not consider the standard deviation, okay? In the categorical variables will not consider the standard deviation, okay? Okay, this way is the best, okay? Thank you. Akash, did you understand? Okay, yeah. Thank you, Shivam. Okay, hopefully everyone understood. So this is it for today. And if any other queries you're having, you may post it in your chat or Q&A. I'll be answering for the next 5 minutes, okay? And if no one is having any other queries, you may leave the session, guys. Thank you. See the training part, Akash, you are referring to the training part, right? And how the models will be trained based on the algorithms. And how the algorithms will be working will not be working through the standard deviation, right? See, previous lecture recordings, Arun, I have informed the team even today afternoon also I have informed them. So they told that they will be updating them, okay? Thank you. Then what are you referring to? So we'll do one thing, Akash. Let me just turn on your mic, okay? Yeah, Harsh, you may leave for now if you're not having any queries. Okay, so Akash, I have enabled your mic, okay? So you can turn on your mic and you can let me know what exactly your query is. No quiz today. No. No quiz, okay?
Hello.
Yeah. You're audible, Akash. Your voice is low.
You fine, sir.
Yeah, it's fine. Please continue with your question.
So my question is, when we label import the categorical values, will they affect their results?
No. They won't be affected, okay? Because the
Why?
model will be learning on the numbers, okay? Just a moment. So the model will be learning on those numbers only. We just need to map back those labels. That's it. We're just mapping those labels over there. Instead of using the categorical variables over there, we are assigning a number for it, and we know what exactly that number refers to. So that won't be affecting the model, okay?
But so while training the model, we use algorithms, and in the algorithms, there are many mathematical formulas are used. So will they affect it?
No. See, I got your question. Your question is, so as we are label encoding these categorical variables, so will it affect the model or else will it affect the output prediction you're asking? Correct.
Uh, yes,
Correct, right? This is what your query is, right? If it is
it's
something
somewhat
different, somewhat you see. So I didn't get your question properly. So somewhat
so
means
far.
I'll
This
just
is
explain this part. I'll just explain this part, okay?
okay.
So if you're still having some doubt, you may ask me. So let's say I'm keeping that Arun, okay? I'm keeping the Arun same. So and the model will not be understanding. So instead of Arun, I'm assuming it as 1, okay? I'm assuming Arun label as 1. And then I'm sending that value to the model. As the model will be able to understand the numerical data, so it will be training on that brand of ice cream column also. Correct. So and it will be able to do the predictions. But what I know that Arun value is 1 over there. I know Ibaco value is 2 over there. NIC value is 0 over there. That's it. We know what label refers to what numerical number. But the model only understand the numerical numbers, so we are just labeling them into the numerical format, and then we are sending them all the columns into the model, and the model is training on all the columns. So there will be the model will not be affected, okay?
But model used algorithms for the predictions, right? And in the algorithms, there are mathematical formulas are used, and
Hmm.
which are
Correct.
totally numerical.
Correct. So instead of Arun, it will be 1 over there. That's it. Instead of Arun, it will be 1 over there. How it will have an impact on textual data? We are assuming it as 1. So will it have any impact? We are assuming a person has X, and we are doing all the calculation. At last, what we need to do? We need to assign that value to X. So what does that particular, I mean, what does it say actually? So we need to assign that value to that particular person. That's it. So instead of mentioning he's a person, I'm mentioning he has an X. I'm doing all the calculations. Okay. I'm doing all the calculations. So wherever the X is coming, there this label should be applied. That's it. So I'm considering this label as instead of X, I'm considering it as 1. Okay. Instead of that X, I'm considering it as 1 and all the operations are happening. So I'm just referring that value as it will be 1 as per the numerical data. And if we are referring to the categorical data, it will be whatever the person name you're considering, or else whatever it could be NIC, Arun, or any other label. Okay. Still having a confusion.
Okay, sir. I think I need to study for the technique.
Mhm. So spend some time. If you're still having confusion, if you're still feeling confusion, let me know in the upcoming session. Okay.
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 Thanks.
Thank you. Thank you, Akash.
Thanks.
Okay, fine. So everyone understood, right? The question is good over there. Okay. Initially, you need to get those kind of questions. Question was good. Okay, then so PPTs will not be provided, sir. So instead of PPTs, only this handouts will be provided. Okay. So today's lecture, it will be taking like up to Friday or else by tomorrow evening. Okay. Okay, fine. So I see no other queries. Thank you. Thank you, guys. Thanks for your time. Oh, you may leave the session, guys. Thank you. Thanks for joining. Yes, Akshay, you will be receiving a mail, right, if you are present in the session.